Today we're going to begin a new lesson and a new operation in math. So we're going to be subtracting integers, and this will serve as your guided notes and your homework. You'll be asked to do 6 problems at the end of this assignment. First, though, it is imperative that you understand the adding rules because we're going to be using those when we work with subtracting integers. We're going to convert all the subtraction to addition so that we can then use rules that we hopefully already know. So let's review this at the top of your page. I know there's not a lot of room, and you can also use your strategy sheet, which is what I'm hoping you're going to do too. So adding integers. Here are the basic rules. When we have the same sign, when we're adding same sign numbers, we find the sum. So we're finding the sum. And in math, that means the answer to an addition problem. So I want you to put a plus sign there. I'm having trouble with my pen right now. Sorry about that. So when we add different sign numbers, then we're finding the difference. And in math, the difference means that we're finding the answer to a subtraction problem. There's one more thing I want to address. Sometimes you're going to notice that numbers are written inside of parentheses, negative numbers, and they usually follow an operation sign of some sort, and that's to draw our attention to the fact that they're negative. It also keeps us from confusing them with the operation sign. So let's move on. When we work with subtraction expressions and equations, it is usually advantageous, which means to our advantage, to change subtraction to addition. We can do this because subtracting a positive is the same thing as adding a negative. So let's explore this on the number line. We're going to start with numbers that you're familiar with. If I had 8, take away 6, you can tell me what the answer is. It's 2. It would look like this on the number line. I would start at 8, and I would move down the number line because I'm taking away. I would end up on 2. And we've talked about the fact that when I have different signs, here I have different signs. This is the same thing as subtracting also. I would take 8 because it had the highest absolute value, and I'd take away 6. It has the lowest absolute value because these are different sign numbers. And it would be modeled like this on the number line. I would start at 0, move to 8, and then when I have a negative number, it moves me down the number line. So 8 minus 6 and 8 plus negative 6 mean the same thing in math. So according to this statement that adding a positive is the same, subtracting a positive is the same thing as adding a negative, I could rewrite this as 3 plus negative 6. And we could write it again using those parentheses. I could have put parentheses here. Generally speaking, that's how you're going to see it. So let's see what this would look like. If I started at 3 and I'm taking away 6, I would move down the number line. And I'm going to land at negative 3. And by the way, we should put the 2 there. So this is the same thing. If you recall, if we modeled this with vectors, we would go to 3, and then we would turn around and go back 6 because it's negative. So that might not be as familiar to us because we're not used to seeing 3 take away 6. We're used to seeing a bigger number minus a smaller number, but it might feel uncomfortable taking a smaller number minus a bigger number. And often students switch those around. So that's why we're going to prefer to write it this way. The next one's even trickier, so let's look at the next example. I see negative 4 take away 6, and this is really uncomfortable because this is all new to us. But based on what we did before, we can rewrite this as negative 4, what we started with, plus negative 6. And that's because our statement up here is subtracting a positive or taking away a positive 6, is the same thing as adding a negative. So we're added a negative 6. Now that we've learned our integer rules, this side actually might be more comfortable for us. So let's see what that looks like on the number line. We would go from 0 to negative 4. So we'd start at negative 4. And then because we're adding a negative, we would move down the number line. So we would move down 1, 2, 3, 4, 5, 6. And we would get negative 10. And here, when I look at it written this way, that might be really uncomfortable because I'm not used to working with negatives, first of all, in the past. And this looks a little bit awkward. However, our new rules that we learned for adding say that if they're both the same sign, we just add them and keep the sign. And that's exactly what happened here. So now that we've learned the addition rules for integers, same signs we add and different signs we subtract, they can be used to help us with subtraction expressions. However, we must rewrite the expressions first. And then there are several strategies we can use. So this first strategy is known as keep, change, change. And we like to abbreviate it this way. And what it means is we keep the first number exactly the same, we change the minus to a plus, and we change the second number to its opposite. So let's try this now. We're going to use a keep, change, change. So I'm going to keep the first number. I'm going to change my minus sign to a plus sign. And this positive 9 is going to become a negative 9. So that's what keep, change, change looks like. And just a little note, we use this just when we see subtraction signs. So we're going to try it again. We're going to do a keep, change, change. So we keep the negative 6, we change that minus to a plus, and we change this positive 2 to a negative 2. Let's try it one more time, and then I'll have you try the third one on your own. We're going to write a keep, change, change. We keep the first number, negative 7. That's what we're given. We change the minus sign to a plus, and we change the negative 8 to a positive 8. So I'd like you to pause. Please do the last one on your own. And then I'd also like you to go back and see if you can answer each of these expressions. Okay, I hope this is what you have for the last expression. Let's check your answers now. Because I see two different signs, I'm going to take 9, take away 4. They're different signs, so I subtract. I'm going to get 5, and I'm going to look and see this number has the highest absolute value. In other words, it would have the most amount of chips or counters, and they would be red. So it's a negative 5. These two are the same, so I'm going to add them. 6 plus 2 is 8, but I'm going to notice that they're both negative, which means I would have all red chips, and red or pink is negative. When I look at this one, these are different signs. 8 has the highest absolute value, so I'm going to take away 7. That's going to give me 1. I notice that 8 has the highest absolute value, would have the most counters or chips, and it's positive, so my answer will be positive 1. And both of these are the same sign, so we're going to add them. They're positive, and so we're going to get a positive 8. So now let's go to the back side, or the next page. This next strategy is called add a line. We add a line to the minus sign, change the sign. So because it rhymes, it's easy to remember. Add a line, change the sign. So what that means is for every minus sign we see, we add a line, and we change the sign of the number behind it. So let's see that again. We add a line to the minus sign, so it now is a plus, and we change the sign of the number behind it. So on the second example, we find the minus, we add a line, so it becomes a plus sign, and we change the sign of the number behind it. Third time, we add a line to the minus, and we change the sign of the number behind it. So I'd like you to stop the video, pause it, and then please try the last one on your own. When you're done, go back and add those together. So the fourth problem would be 6 plus positive 1. When we start with this, I'm going to notice the first one, they're different signs, so I subtract. So I'm going to get a negative 3. This next one, they're different signs, so 4 take away 3 would be 1, and I notice that the 4 would have the most chips. It's negative, so it's negative 1. These two numbers are both the same sign, so I add them. I get 9, and they're both negative, so the answer is negative. I keep the sign. When I look at this, 6, positive 6 and positive 1, they're the same sign, so I add them, and they're both positive, so I keep it positive. So I know this lesson's going a little bit longer than usual, but there's a lot to get in. So if you would with me, would you please now look at the middle section? This is extremely important that you know we do not change addition signs. It's only subtraction signs. We like our addition. We've worked really hard to learn those rules. So, and the add a line, change the sign may be a little bit more helpful when you have expressions with several integers. And here's why. I'm just going to skip right to where I see a minus sign, and I'm going to change that minus by adding a line, and I'm going to change the number behind it. So now let's look at what's coming up. We have 3 minus 5 minus negative 2. So I'm going to have to change 2 of those. I'm going to start with this first minus, and I'm going to add a line, make it a plus, and change the number behind it. I'm going to do the same thing for the second minus, add a line, and I'm going to change the sign of the number behind it. So would you please try this add a line, change a sign on the next expression, and then start the video and look to see if you agree. If you'll notice, there was only one minus sign, so we only had to add a line and change the sign of the last part of this. Now, we're going to get to these type of expressions coming up. They're multiple integers, which means many, and we're going to go back and try working on those in a different lesson. So for now, it's your turn. Would you please change the following expressions to addition using either KCC, which means keep, change, or add a line, change the sign. You can look back at what we did on the notes. I also want you to find the answer after you change them to addition expressions. And if you look at letter F, I did include one in case you want to try multiple integers as a challenge. Love for you to try that. Please make sure you complete this on paper or take a picture and attach it or complete the online version. Thank you.